Hello, and thank you for joining us today. Welcome to our session, ArcGIS API for JavaScript, working with your data using the feature layer. All of the slides and demos for today's presentation will be available at the link shown right here. So some quick introductions. My name is Ann Fitz. I'm a product engineer on the ArcGIS API for JavaScript team, and I've been at Esri for about 2 years. Here today with me is Bjorn Svensson, the lead product engineer on the JavaScript API, who has been at Esri working with web technologies for the past 20 years. So today we're going to give an introduction to the feature layer, then we'll talk to you about the performance and what's going on under the hood. We'll talk about all the different ways you can visualize your feature layer, and then we'll talk about labeling. Then we'll talk about ways to interact with your feature layer, like through pop-ups and querying and highlighting. And lastly, we will talk to you about editing your data in the feature layer. Lots to cover today, so let's get started. So first, what is the feature layer? We support more than 20 different layers in the API, though I'd have to say that the feature layer is one of the most powerful. The feature layer can be used for querying, visualizing, and analyzing your data. It provides client-side rendering, and it's typically service-based, though sometimes it can be file-based. So, what's so special about the feature layer? It works with your data as features, allowing support for filtering, querying, and statistics done on the client side. It can also be used for editing features and dynamic styling and interactive workflows. And Bjorn will talk to us in just a bit about the performance of the feature layer and what makes it so special there. Okay, so let's talk about how to add a feature layer to your map. There are 3 different sources a feature layer can come from: either a feature service or a map service, a feature collection, or a portal item from ArcGIS Online or ArcGIS Enterprise. Let's take a look at each of these sources in some sample apps. So first, let's take a look at a feature layer created from a feature service. So in this example, we have the feature layer in our require statement. We have it there, and then down here, we're creating the feature layer just by the URL to the service. So let's just take a quick look. Oh, and then we add that to our map. So let's take a quick look at what that looks like. All right, so here you can see we have this basic polygon feature layer of housing in each county. Let's go back, and I'm going to uncomment this section on the renderer. So now we're setting a simple renderer with some visual variables on the layer. Let's refresh. Okay, so now we're looking at areas where the percent of vacant housing is less, where there's less vacant housing, and then the areas that have the smaller symbol are more vacant housing. So as you can see, this adds a little bit of extra work to add this renderer. This is something you don't have to do when you are adding a feature layer from a portal item. So here, where we're adding the feature layer, we are just specifying the ID of the portal item. So that would be referencing a layer that was created in ArcGIS Online or ArcGIS Enterprise and styled using the map viewer there. So let's take a look at what that one would look like. So here you can see we have pretty much the exact same layer showing the vacant housing percent. The lower percents are our larger symbols, but we're using much less code, just referencing that portal item ID. Okay, so the last source option is to create the create the feature layer from a feature collection. So in this sample that can be found in our online documentation, it shows how to create a feature layer from client-side graphics. The graphics are created from GPS data, extracted from EXIF data from a set of images. So if we click on the pop-up, you can see the related image. So here, when we create the feature layer, We set the source to the array of graphics from the EXIF data, and then we specify the object ID field for the unique IDs set on the source. Then we'll specify the array of field objects. So this will provide the schema of each attribute field. And then we can also just set the pop-up template and the renderer for the layer. And then we just add the layer to the view. So working with client-side graphics is pretty simple and straightforward, and definitely one of the options that the feature layer provides. So now I'm going to go back to our presentation. So we already talked about adding a feature layer to your map. So now I'm going to pass it off to Bjorn, who will talk to us about the feature layer network performance.
Thank you, Anne. Let's talk about feature layer performance. On the ArcGIS platform, we're doing a number of things for optimizing performance. This includes using the Brutley compression, a prototype buffer format for data format. This is a Google binary format that allows for smaller payloads and thus better performance. The ability to cache is crucial for better performance. Making consistent queries makes this possible. One aspect of this is having the API send tiled requests and having ArcGIS server taking advantage of using dynamic feature tiles. This allows for better caching from the browser, the CDN, and from the server. Next, let's look at demo of network traffic. In this application, I have a feature layer with about 3,000 polygon features representing the county and county equivalents of the United States. You can see at the initial load there was 4 requests. These represent the 4 feature tiles. As I pan, you'll see there's 2 more requests coming in, representing 2 additional feature tiles being requested from a server. Now let's take a closer look at the response header for these. If we look at the response header, we can see that the content encoding is BR, which stands for Brutley, and the content type is PBF, prototype buffer format. Now, in the case of a user who is in the same browser and is reusing the application many times, we can disable the cache and see what they experience. You notice that the disk cache is being used. So this is the case of a user who's requesting it from the same browser. Now, in most times, your user will come from different browsers, and so a better equivalent of that is to disable the cache and see the behavior of that. Each time we're making a request from the server, the Xcache can show us if it's a refresh hit, which basically means that the server has some data, but is checking if it needs to be refreshed. If we zoom into a more detailed area, you'll see that some of these returning a miss from CloudFront basically means it didn't have the data before. If another user or yourself is coming back to this area, then it would see that data is being refreshed, hit, or hit. What if you have a data set with a lot more data points? So for example, you might have a feature layer with 360,000 points spread around the world. Now, instead of being 4 requests for the tiles, what's happening is there's a subsequent tile separation. So if the data cannot be returned in one tile, we split the tile into 4 tiles and request those 4. If any of those have more data can be requested in one request, then we will also subdivide that into 4, and so on until we have all the data being sent and available in the client. One thing I want to point out here is the cache control. For the first layer, the max stage was 30 seconds, while the second layer was 3,600 seconds, also known as an hour. This is one of those settings where you have control over in your feature layer. If you have control over the feature layer, one of the first things you want to do for good performance is making sure that it's public. So make sure you share and make sure it's set to public. The second part you want to make sure it's happening is that it's not editable data. Now in this case, I've already made sure that it's not enabled. The first setting, which relates back to the cache control we just saw, is how long do you want users to not find out if there's new data. If you know that your data is very stable, meaning maybe you update it once a year or once a month, you can set this to 1 hour. This is the longest. The default is 30 seconds. But if your data is not being updated, which most data is not, I would recommend you increase that to at least 5 minutes. So to summarize some of the options that you can specify for optimal cacheability. Number 1, disable editing. Number 2, make it public, set the share level to everyone, and 3, increase the cache time. On the first bullet points here about create editing on the feature layer, I think it's important to also talk about view layers. If you have a layer that's being updated, you can create a view layer of that that's not editable and thus can be cached better.
Thanks, Bjorn. So next we're going to talk about visualization. Now to visualize your layer or create a style for it, you will use what we call a renderer. There are many different kinds of renderers, as shown in the table here. Simple renderer, class breaks, etc. A good place to start out is the visualization guide page to get a good feel for different visualizations. So as you can see, this guide page walks you through what type of visualizations are possible. You can use location only, you can use thematic data-driven symbolization, and it gives you options for how to create them. You can author in ArcGIS Online using the map viewer, or you can manually construct your renderer in the code, in the section on manually defined renderers. So let's go back to our presentation and take a look at an example. So first we're going to look at a simple renderer and how it works with the feature layer. So let's take a look at the code actually. So here you can see we're just setting the render. So we have our feature layer and we're pointing to a feature server. And here we're setting the renderer. So we just want to use a type simple. This will autocast to simple renderer. And then we'll just set a symbol on it. So in this case, since it's a polygon layer, we want to do a simple fill symbol. And we'll just set a color on that symbol and set an outline. And if we go back, we can see that this is what it looks like. And we have our legend up here that gives us the symbol for the layer. So this layer is representing the employment status by county. And the simple renderer isn't really telling us much about the employment status in each county. But it does show us where the counties are located and the boundaries of the counties. So we can take this a little bit further by using a class breaks renderer. Okay, so let's take a look at class breaks. So here you can see we're doing the same thing, same feature layer, but we're setting the type to class breaks. And now we get to decide a field that we want the layer to be rendered by. So in this case, we're looking at the % unemployed. And then we can set our class break infos, which will set a symbol based on the value of this given field. So in this case, we're looking for where we'll give a specific symbol for 0 to 4%, another symbol for 4 to 6%, another symbol for 6 to 10%, and another symbol for greater than 10%. So let's go back to our demo, and this is what it'll look like now with the class breaks renderer. So you can see areas like over here where there are a lot of people unemployed versus over here the number of unemployed people is less. Our legend will update based on the given renderer. So this definitely tells us a lot more information about what kind of data we have in our layer. So next we're going to take a look at an example using visual variables. So visual variables are used to create data-driven thematic visualizations. And you can vary the color, size, opacity, and rotation of your symbol based on the attributes of each feature in your feature layer. So we're just, here we're just using the same simple render with just a basic simple fill symbol. But now here, we'll set our visual variables. So these get set on the renderer. And we want the color of the symbol to be updated based on a field type. So we're looking at the same field we looked at for class breaks renderer, the % unemployed. But now we're just going to give it certain stops. So At 0.6, which is our lowest value of that field, we're going to set a specific color. And then about halfway at 5.3%, we want to give a different color. And at 10%, we'll give it a different color. So this will create a continuous color ramp that will show our data. Okay, so let's look at the visual variables. So now you can see that there's this continuous color ramp starting at this light pink color and going into a dark red. So it's similar to the class breaks renderer in what we're seeing on the map, but instead of just being divided by certain percentages, now we have this like color, continuous color flow into the next, and it creates a pretty nice looking map. Okay, so next we're gonna look at we're going to talk about smart mapping. Smart mapping is another form of visualization that generates a renderer for you with a smart default based on your data and the base map you chose. Okay, so let's try out some smart mapping using the same layer that we've used to do all our other rendering demos. Okay, so in our require statement, we're bringing in a couple new modules, the color renderers module, the histogram module, and the color slider module. Here we have our featured layer. We're just bringing it in based on this same feature service, and that's kind of it. We're setting the min and max scale, but no rendering or anything applied there. Next, okay, down here is where the magic happens, the smart mapping magic. So we're using this color renderer creator to create a continuous renderer. So that will kind of be similar to the visual variables continuous color ramp that we had. All we have to do is provide the layer, the field that we want to visualize, so in this case % unemployed, the theme, in this case high to low, and the view. And then we also are just setting outline optimization enabled to true to make the outline thinner for smaller scales. Next, then we'll apply this, would get this renderer result and apply that to the layer renderer, and then add the layer to the map. That's pretty much it. So let's see what that looks like. Okay, so here you can see that we get this default, this renderer, and it's giving us this color ramp that works nicely with our background. Oh, and I forgot to mention this color slider, so I'll show you kind of how we did that first. So there's this histogram that we brought in earlier. So we'll just, same thing, we provide the layer, the field, the view, and then we can set the number of bins we want to show. And that histogram result and the renderer result combined will give us what we need to create this color slider. So then that's a widget, that's a smart mapping widget that we can add to the view to change the color rendering based on like the values that we dragged to. And this histogram just helps kind of show you where the values are of that field. So I mentioned that smart mapping is based on the view and the data you provide, but also the base map that you use changes the smart mapping that's applied. So let's go back and let's change this dark gray vector base map to just a gray vector base map. And then let's go and refresh our data, or refresh our demo. And smart mapping does take a while to do because it has to look through all your data and then go ahead and create the layer based on what your data is. So it's good to use if you're just exploring your data within the layer or if you're creating a data exploration app, but it's not something you would want to use every time you load your layer because it's much slower than specifying the renderer yourself. Okay, so we finally got our layer to load. You can see that the color has changed based on what looks better on a lighter base map. We can still use our little color slider to play around with the values, but yeah, using the base map, changing the base map will change the what is returned from the smart mapping creator. Okay, so that was smart mapping. Next, I want to briefly talk about clustering. Clustering is a method of reducing points by grouping them into clusters based on their spatial proximity to one another. So this was something that was released in 4.16 over the summer, and we've continued to add more support for labeling and pop-ups and stuff like that. So clustering is a pretty new capability within our API, and there's a whole demo theater about it that I recommend you check out. But let's first look at this app. So this is without clustering enabled. Lots of different point features. Kind of nice to point out, this is also using a couple different visual variables. The air temperature is by the color visual variable, and the rotation of the symbol is from the wind direction visual variable. Okay, so now let's go to our app and we'll just apply some clustering. So to do this, we will just set the feature reduction property on the layer to type cluster. So let's go back to our app and see what that looks like. Let me refresh. So now you can see that the symbols have been clustered together, so the bigger symbols represent areas that have higher numbers of features, and as you zoom in, the clustering updates based on their zoom level. Okay, so that was all I had for visualization. Now I'm going to pass it off to Bjorn, who will talk to us about labeling.
Now, let's talk about labeling. Labeling is an important part of a great map. You can use labels with FeatureLayer, CSV layer, Scene layer, ODC FeatureLayer, and many similar layers in our API. While there are differences between these, the basics apply to all of them. The feature layer has two main properties we're going to talk about. Labels visible allows you to quickly turn on or off the labels. Labeling info is an array of label classes which allows you to specify the what, the how, and the when of your labels. The label expression info defines the content of the label. It's an arcade expression and can be as simple as a field, or it can be a more complex arcade script. Label placement describes where, relative to your feature, the labels will display. Max scale, min scale, and where allows you to filter when these labels should display. And the symbol allows you to set up the formatting and the styling of your label. How should your label look? The text symbol can be used in 2D and 3D, and label symbol 3D is an option only for 3D. Now, let's look at some code. In this application, we have a feature layer with mountain peaks. We're using unique value renderer to show the peaks as green or red depending on if I climb them. We have specified in the labeling info two different label classes, each one matching up with the red or the green triangle peaks. In the first label class, we specify the where statement as climbed yes. We have a simple expression that only displays the name of the mountain peak. In the second label class, we're specifying for no, which ones we haven't climbed. And the expression is a little more complex. We start with a name and a new line, and then we're displaying the elevation. But we're displaying the elevation formatted with a comma and ending with feet as the unit. Another aspect here is you can see is that I've been specifying the min scale. You might not want to show the labels as you zoom out. So in this example, when you have a lot of the features on the map, displaying the labels at the same time might not be very productive. Now let's look at a 3D labeling example. This example is straight out of the documentation, and what you can see here on the right side is that the labels are smaller when they're further apart and when they're bigger when they're closer. This is something that's specific to 3D, and there's a property called screen size perspective, and it's true by default. The basics for labeling is the same in 2D and 3D. So we have a labeling info, and in this case, I only have one label class. I've specified a label expression info with an expression that's an arcade expression. Where it's a little bit different is in the symbol. In this case, I'm using a 3D symbol. I'm specifying it as a text symbol, what color I want, But one thing I want to point out is the callout. In this case, it's a callout line that connects the label with the actual feature. In 3D, you might come up with cases where the labels are not, the feature are not visible because they're hiding behind another feature. So a callout line is a great example to call that out. And lastly, I want to point out that we have a specific documentation page just for labeling. It contains a lot of the details about which fonts can be used and what settings can be used for different layers and different views.
Thanks, Bjorn. So now that you've learned how to visualize and label your layer, let's talk about how you can interact with your layer. There are many different ways to interact with your data and features using the feature layer. The most common way is through pop-ups. Pop-ups allow you to click on a feature and view content from the feature's attributes. Pop-ups can be used to display images, charts, and other custom content you might want to add. To add a pop-up based on your feature layer, all you have to do is set the pop-up template property on the layer. Let's take a look. So here is a sample that's using a basic pop-up. So if I click on a feature, we get the census tract name, we get the county name, we get some fields from this feature. So let's see how this is done. All right, so here we have the template. This is AutoCast as the new pop-up template. We're setting the title, and everything in these braces is representing a field name in the layer. So this name is what here is Census Tract 50, and this county is here what is Bergen County. So then we have our title, and now we can set the content. So this takes an array of pop-up content. In this case, we're just doing one type of content, and that's a fields content. You can also do media content and show images or charts, or text content and just put text. This fields content will show our fields in a table. So here we just set the field infos. We set the field name to the field in our feature layer, and we can give it a specific label that we want it to show. And there's other things we can do like format and whatnot. And so to add this pop-up to our feature layer, all we have to do is set the pop-up template property to the template we just defined. Okay, great. So another way you can interact with your layer is through widgets. We provide widgets that allow for easy UI interactions with your layers and data. For example, the Legend widget displays labels and symbols for layers on the map. The Layer List widget allows you to toggle on or off the visibility of your layer. You can see both of those widgets in use in this GIF right here. Lastly, you can interact with your layer by using its querying, filtering, or highlighting capabilities. We'll get into that in the next couple of slides. But before we start talking about querying and filtering, it's important to first talk about the difference between a layer and a layer view. We've spent the majority of this presentation talking about what the feature layer is, how to create it and render it in your map, but the layer view is actually what is actually responsible for rendering features in the view. It's created when a layer is added to the map view or scene view, and it allows for querying, filtering, and highlighting on the client side, which means that these actions will occur within your web browser without making additional requests to the server. In the image shown here, you can see the difference between a layer and a layer view. The app's initial extent is shown in this little red rectangle at the center of the map. These are the features that are available in the layer view or on the client side. So any filtering or querying will only apply to these features. Any filtering or querying on the layer view, I mean. The layer represents all of the data shown within the map. So any queries done there will search through all of that data. It's kind of small in the top right corner, but you can see in this map, the layer view query returns only 6,951 features. But the same query on the layer will return 12,726 features. And we'll dive into this a little more in a discussion about querying. So there are 3 different query types: attribute queries, spatial queries, and statistic queries. Attribute queries are based on a where clause. So you could say, I'm looking for features where population is greater than 10,000. Spatial queries are looking for features within the bounds of a given geometry. And statistic queries return statistics from the selected feature. Okay, so server-side querying means that you're going to the full data source of the server, performing the query there, returning the results, and bringing the full resolution geometries back. This type of querying happens on the layer. So let's take a look at this demo to see how querying on the layer works. When we click anywhere on the map, we get the results. So we're looking for post offices within a mile of where I click. So in this area, we're getting 3 different results. So let's take a look at the code. So here we have our feature layer, and we have a pop-up template set, we have a renderer set, and down here is where we are saying view on click, and then we're calling this query features function. And in this query features function, we're taking the screen point, so where we clicked on the screen, and we're using that point to query, to feature layer query features. So we set that point as our geometry. We can set a distance. Oh, sorry, it was half a mile, not a whole mile. And we're looking for places where the features intersect with our geometry. And yeah, and we're using a where clause to state we're only looking for UPS locations or other post office locations. So once that promise resolves, then we're given a feature set with all the features returned from our query, and we can add those to our pop-up with the results. Okay, so let's take a look at the network requests here. So now whenever I click, you can see that a new network request is being made to the service every time with that query. Okay, let's take a look at, next we're going to look at client-side querying. When we query data on the client side, we're just querying data that's already available in the web browser. So this helps us to avoid round trips to the server. This is done on the layer view instead of the layer. One thing to watch out for is to make sure you have all the attributes you need by setting the out fields in the feature layer initialization. If you query for an attribute that is not included in the out fields, nothing will be returned from the layer view query. There are some limitations to this client-side querying. This only works with the features available in the browser, and the returned geometries are simplified. So let's take a look at this client-side querying demo. So it's pretty much the same as the server-side demo. We're still looking for post offices within a half a mile of the click location. But now let's take a look at the network requests. So we can see every time I click, there's no new requests going through. So this is all happening on the client side. Let's take a look at the code so we can see what we're doing differently. Scroll down. So here we are in the querying. Now we're looking for the layer view. So we're looking, once this layer is created, we're calling view when layer view, and that will return our layer view. So basically everything is the same, except now we're just calling query features on that layer view instead of the layer. Okay, so this looks like pretty much the same as the server-side querying example. We're not really seeing the benefits of client-side querying. But now let's take a look at a different sample that queries based on when you hover in the map. So now we can see that as I move my mouse, the query is updating immediately based on the new location. And this is the great thing about client-side querying, is that it can happen really, really fast, and these additional requests to the server don't need to be made. Okay, so let's go back to the slides. Next, we're going to talk about highlighting. Highlighting is another thing that happens specifically on the layer view. After querying, you can highlight the features returned from the query. Let's take a look at this sample in the SDK. So this is a view hit test sample. So when I hover, and we're calling a hit test whenever my mouse moves. So that will see if there's any features underneath where my mouse is. And then we're going to highlight the feature if it's there. So here you can see in the map view, we have this highlight option set so that the color is orange. Normally the default highlight color is a cyan color. Okay, and then down here, here we go. So we are doing a query, we're doing a hit test, there's lots going on here. Once we get the results of our query, we are going to highlight wherever the feature is, returned. Sorry, here we go. We're querying for the object IDs for the hurricanes that are the same year and name, and then we are setting the highlight on the layer view. So it works pretty fast, and as I move my mouse, the query happens and the highlight happens immediately. And that's all done on the client side. Okay, so next I want to talk about filtering. Filtering is also mostly done on the client side. If you want to perform a server-side filter, you can use the definition expression property on the layer. So just really quickly, I wanted to show you this definition expression. This is the same sample that we were looking at earlier with the percent unemployed using visual variables, but we're using a definition expression so that we're only looking at the state of California. So when that initial request is made to the server, we're only requesting the features that are in California. And if we look at the code here, that is just something that's set on the feature layer right here. Very simple, definition expression, state equals California. So there's that. Next, I wanted to talk about client-side filtering. So to create a client-side filter, you want to define the filter criteria, and then you can choose to define a style for the filtered features. Then you apply the filter to the layer view. Let's take a look at this demo. So here we're looking at the same sample that we used to show clustering earlier. Right now we don't have the clusters applied actually. I just added this drop down in the top left corner that allows the user to filter by a certain speed, wind speed. So when I click on this, only the filtered features are shown and the other features are kind of grayed out, have an effect applied to them in the background. So let's take a look at the code. Here we're looking at this filter code and we have our render set, all that we did earlier. Down here is our filter by wind speed event. So we're using the layer view when the items in that dropdown are clicked, then we're calling this filter by wind speed. And that gets the wind speed from that dropdown and applies that to this filter variable where we're saying where wind speed equals the wind speed that we specified. And then we're setting that as an effect on the layer view. So we'll apply our filter and then we can set an effect on the excluded features. So any feature that was not included in this filter, we're going to set the opacity to 50 and the brightness to 50%. Yeah, so then once we hit the drop down, then those features that are excluded are filtered out. So that finishes up our section on interacting with your featured layer. Next, Bjorn will finish us off with a discussion on editing.
Thank you, Anne. Let's talk about editing. Key aspect of editing is having an editable feature layer. There are also other layers that you can edit, but this session is about feature layer. For a hosted feature layer, go to the settings of its item page. Here's where you can enable editing. Note also the many options for specifying more fine-grained control. For example, do you want to keep track of when a feature was created or updated and who did it? For the editing, would you like people to be able to add it, delete, or update? For example, you might want to have an application where people can add features, but people in general will not have access to updating existing features. Or you might want to have an application where people are not allowed to delete any features because you have regulatory rules that allows you not doing that. You might all want to set up options for who can see different features and who has access to edit the different features. Note that while these settings are set in stone on the service here, in the API itself, you can also further limit these controls, even if they haven't been set on the service. So make sure that you enable editing for your feature layer. There are multiple options to enable editing in the JavaScript API. The easiest out-of-the-box experience is using the editor widget. The editor widget will look in your map and see if there's any editable feature layers and then allow you to start editing with them. Another option is using the feature table widget. You can enable editing for the layers within it, or specifically for certain fields if you want to. Both these widgets take advantage of the feature layer apply edits method. This is the key. It still has the logic for communicating between your browser and the server and the editing in between. Another option is to use something like a feature form widget for attribute editing and then hook it up with a feature layer apply edits to manage the communication to the server. Let's look at some samples to show editing. Just like many other widgets, it's as easy to use as creating the widget and then adding it to the UI. Let's look how this works. If you want to add a feature, you decide on which type of feature you want to add and then click on the map. And if there's any attributes, you populate them and then click add. When it comes to editing features, you select on the map which feature you want to edit. And then you can either edit any of the attributes, move the feature around, or decide that you want to delete the feature. There are many samples in the documentation. One sample I want to point out is the pop-up with edit action. This is a slightly different behavior than what we saw using the out-of-the-box experience. This sample is a little different from the first sample you saw with the editor widget. Here, we have a pop-up with a custom action called edit feature, which then enables the widget, the editor widget. So again, we can change the attributes and then update the feature. Let's take a look at the source code of this application. There are a few different steps I want to point out. The first, we've added a custom trigger to the pop-up. In this case, when it's being called, we call a function called editVis. In this function, we're doing a few things. The key aspect here, I think, is the editor. We're jumping into the editor halfway into the workflow. So we're skipping the part about where people have to select if they want to add or edit. Once we've done that, we add the editor so it's visible. Then the user edits the feature and finishes the editing. The last step is that we're listening into when the feature layer has been calling the apply edit. So the widget itself, the widget will call the apply edit on the feature layer, and then we're listening for that action. And when that happens, we remove the editor and go back to showing a pop-up template. In addition to the samples we have in the documentation, there are also 2 sessions at this developer summit. One of them is called Web Editing in 2D, which is in a few hours. And we earlier in the week had a Web Editing in 3D session. So please watch these sessions. On behalf of my co-presenter Anne and myself, thank you for listening. Hello, and I hope you enjoyed that session. And now we're on our Q&A part of it. So if you have any questions, please enter it on the right in the little Q&A tab there, and we will go through the questions. If you read other people's questions, please vote them up, and we'll ask the questions with most votes first. Starting off with, is there a practical limit on how many feature layers can be included in your app? For example, can you easily have 100 layers and so on? So in general, you shouldn't have 100 layers. Most of these, there's no real limit. You can have as many as you want, but your browser memory basically is what's going to limit what you have. When you start up your application, if your feature layers are in a view, we will make a request for all of them at the initial. So having 100 of them, it's not going to be good for your performance. But once it's loaded, they will display just fine.
All right, so then the next question is, why does this need to be public and not organizations shared? Do you want to talk about that one, Bjorn?
Yeah. The reason why it needs to be public is that the way our CDN, the CDN on ArcGIS Online works is basically that for unprotected data or public data, we can cache it better and we don't have to check authentication as much. So that's why public data will be faster performing because we can cache it more in different places.
Awesome. So the next question is, can you talk about the differences between feature layers and graphic layers? Do the renderers shown in the presentation apply to graphic layers as well? So the answer there is no, the renderers do not apply because there is no renderer property on a graphics layer because the graphics layer does not have any attributes. So you can render your graphics layer with certain symbols, but you cannot use a renderer to render your graphics layer because there are no attributes to show there. All right, next question. How do we manage the cache control when using ArcGIS Enterprise and layers are not shared with everyone? Is it possible to take advantage of caching in this case? Do you want to share that one?
Yeah, so we probably didn't point it out enough in the presentation so far, but most of the features we were talking about relates primarily to ArcGIS Online and the caching on there. In the case of having Enterprise, those are your web servers and not the ArcGIS Online maintained web servers, so that it works a little different. And I'm not sure exactly how you can make that work, but I would recommend you go to the Ask Our Experts and ask that in the Enterprise section.
All right, next question. In order to improve the feature layer performance in version 4.19, is there any additional processes required when publishing feature layer to ArcGIS server or configurations in ArcGIS server for the tiles compressed format? Do you want to take that one too?
Yes. You do not have to, I mean, the answer is that no, you don't have to do anything else. You know, the 4.19 API will automatically do that part based on how your feature layer is. And so just like we talked about in earlier, the things about improving performance, that would still apply.
Okay, and then there's a follow-up question that just got posted. Can on-premises feature services for caching that are shared to the org still utilize cache, or just, is it just slower? Or if it's not public, it doesn't work at all?
So when we talk about caching, the caching can happen in a few different places. There are caching like in the case of ArcGIS Online, there's happening in our CDN, but when you're using Enterprise, there's no CDN getting in place, but there's still caching happening on the what we've been talking about, feature tile caching. Now, feature tiles are supported starting with ArcGIS Enterprise 10.9. So if you have 10.9, or once you have 10.9, then the feature tiles will work for enterprise hosted feature services.
Next question is, how many features maximum can the feature layer view hold? And I think this answer depends on what device you're using. We don't have a maximum set, and Bjorn, correct me if I'm wrong. Do you want to comment in on that?
No, you can have as many as your device supports. I've had feature layers with 1 or 2 million features. Obviously, in the initial things, you're going to have to download them, but we made a lot of improvements of that. Then it comes down to memory. If you have a very old iPhone, for example, it's going to crash a lot faster than a modern, desktop.
Okay, awesome. And next question is, what is the process of saving a feature layer? So this is something you can do if you're like updating the renderer. This is something you can do in the map viewer. So if you wanted to update your renderer in the map viewer and then save it, that's something you can do there. I'm not sure, I would have to double check if there's a way to do that from the API. You can save it as a web map, and that would be a way to save your feature layer. That would save all of the rendering and any other things that were applied to your feature layer. But I would have to check on saving the portal item specifically. Next question, I've added feature layers with utility network enabled feature services. Is there any plan to have a new layer type that extends feature layers with additional UN-based capabilities?
So I gave a very short answer, which was yes. So we are working on support for utility networks in the JavaScript API. It's not available yet, but it will be coming in future versions.
Awesome. Did we answer this first question already? I don't remember. In order to improve the feature layer performance in Core?
Yes.
Okay. All right, next question. What Esri server technologies will use protocol buffers for feature service export? Online portal ArcGIS server. If I have a federated server, will that let me use some of these advanced feature layer services? Do you want to take that one?
So the question is about PBF or protocol buffers. And I don't remember what version of Server Enterprise that was added in, but it's been in quite a few versions. And in the API, I think it's all versions of from 4.0 and forward that takes advantage of that.
Cool. Do you recommend using feature services with no editing capacity instead of map service for performance?
That's a great question. And I don't really know the answer. I haven't tried. I think it would depend if you're using ArcGIS Online or Enterprise. My gut feeling would be that feature service with editing turned off would perform better, but I haven't tried that. And so that would be an interesting thing to test. And of course, all the performance things about feature layer, like turning off, making it non-editable and setting caching, all of those would apply.
Next question, is the code going to be available or is it in the developer JS samples? We used a mix of custom code and stuff from the developer samples. I will post those links to the slides and the demos. I just added that as an announcement in the top, so you can access both there. Okay, next question. Is it possible to have some queries use server side and others use client side, or is it only one or the other? Yes, you could do both. You can do server side queries on the layer, and then you could have a layer view where you're doing client side queries. You can also use a definition expression when you're creating your layer if you wanted to only request certain features from the server. But that is not something you can like update after your layer is loaded. Like the definition expression will only get those specific features, and then that's what you'll have to work on the layer view. So yeah. Next question, can I switch renderers on any feature layer or do I need to have a specific feature layer for specific renderers? So this kind of depends on the type of feature layer you have. If you have like a point line or polygon feature layer, if you specify a certain symbol on your renderer, then you will need to like update that symbol based on the type of layer that you have. But if you're not specifying the symbol and you're just using the default symbol, like a simple renderer will default to a simple point symbol. If you're using a point layer, and if you're using a polygon layer, it will default to a simple fill symbol. So yes, you can switch renderers on the feature layer, but it gets a little more specific when you get into the symbology stuff. All right, do you want to take the next question, Bjorn, about labeling?
Yes. So the question is about line labeling and what options are available, basically, or why something doesn't work. So in the API, we don't currently support all the label placements for lines. And if you go to the documentation for label class, and if you look under label placement, you can see that we dock that for feature layer polylines, we only support center long label placements in the 2D map views. So that's the current support.
Awesome. So next question is in which JavaScript API version was the feature layer view introduced? And this was introduced at version 4.0, so in the beginning of 4x. Next question. Can I force the API to use JSON instead of PBF? This is for when doing development, so I can see the responses in DevTools. Do you want to take that?
Sorry, I'm not seeing that one on top. Could you, where is that one? Could you, or just read out again?
Yeah, can I force the API to use JSON instead of PBF? This is for when doing development, so I can see the responses in DevTools.
In the API out of the box, there's no way to change the support of that. You could take the query that you see and open it in a new window and change the PBF to a JSON parameter. I think that would be the easiest way to do that.
Sounds good. Next question, can you provide a URL? So yeah, we provided a URL in the response. So do feature tiles support non-hosted feature services from Oracle-based EGDB? Do you want to take that one, Bjorn?
Yeah. So it doesn't really matter. The Oracle-based EGDB doesn't matter. It's about how it was published. And so like I mentioned before, for the feature tile caching, I believe it's the 10.9 that you need, and that works for enterprise-hosted feature services.
Awesome. Next question, you can't specify the class breaks or other renderer in Pro or via the web map. You would need to use or modify HTML. No, you can specify it in the web map. You can, or you can do it in Pro and save that to a web map. We were just showing an example using code, but you can specify it in a web map and just reference the web map. And that goes with any renderer. Someone pointed out that it is possible to change a feature layer's definition expression after the layer is initialized, but it will cause another call to the server to download the new set of features. So the performance isn't great. Thank you for clarifying that. Sorry for my misspoke. I don't know how to say that in past tense earlier. Okay. Next question. In a web app builder, I have a feature layer made from a map service layer. Does it request all of the attributes for rendering or just the geometries?
I can take that. First off, remember that in web app builder, there are two versions, the 2D and 3D. In the 2D version, it's using the 3x API, and in the 3D, it's using the 4x API. This session has been all about the 4x API. In general, for web builder, when it's doing the request for feature layer, I don't actually know how it is requesting. And the easiest way to find out would be to look at the request. I believe it's requesting all fields, but I'm not 100% sure about that.
All right. Next question for the hit test example with hurricane paths. Is it possible to highlight all intersecting features rather than just the topmost feature? So the answer is yes. With the hit test, you can get the the topmost feature, and then you could perform a query for, like, if you're looking for intersecting features or features with a certain attribute. And then you can highlight based on the results of that query. So it is possible to do that, yes. Next question, is it possible to select more than one feature and edit a common attribute at once? Do you want to take that, Bjorn?
Yeah, I can take that. So the answer is yes. There are two options there. If you're using the out-of-the-box widget, then it's not yet possible, but it is something we're working on so that you'll be able to basically, on the screen, you draw a rectangle or select with your keys multiple features, and then you can edit from there. For right now, you would have to do it in your code to edit multiple attributes and then send it in with an apply edit.
Okay, does the editor widget function with related data?
That's a great question. I don't know the answer, but I think it's no, but I thought we did some support of related data, but most of it, actually, no, I know the answer. So yes, it can work with related data that's set up, and you can edit those. There are some restriction, I think, between the one-to-one and one-to-many, but I don't know the answer for that. If you want to know the real answer, I would go to the Ask Our Experts, and somebody who knows the editor widget better would be able to answer it there. And in general, sorry.
That's all we have time for. I think we're done. We're done here. So thank you so much for coming. If you have further questions, bring them to the Ask Our Experts web development channel, and we'll be happy to help. Thank you.